So, what would it take to power our entire world on clean energy? No more fossil fuels. Well, it's not just a dream anymore. It's a real engineering puzzle. And the key to solving it might just be the biggest battery you can possibly imagine. Let's jump in.
Okay, so here's the fundamental problem, right? We have all this amazing, clean energy coming from the sun and the wind. But what do we do when the sun goes down? Or when it's just not a windy day? How do you keep the lights on 24/7?
To figure that out, we really have to get our heads around what's called the renewable energy dilemma. And it all comes down to the way our electrical grid is built.
I want you to think of the power grid as this incredibly delicate high-wire act. Every single second of every single day, the amount of electricity being made, that's the supply, has to perfectly, and I mean perfectly, match the amount of electricity being used, that's the demand. If that balance is off by even a tiny bit, the whole system can get shaky and even crash into a blackout.
And this brings us to the real troublemaker, variability. You see, a traditional power plant is something you can control. You can ramp it up, you can dial it back. But wind and solar, they do what the weather tells them to do. And that unpredictability makes that high-wire act for the grid operators, well, a whole lot harder.
And this chart right here, it shows you the problem in living color. That red line is the power we all need throughout the day. The green line is what we're getting from the wind, so that blue line, that's the gap. That's what all the other power plants have to scramble to fill. See how much more jagged and wild that blue line is? That is the chaos that renewables can introduce.
So, the billion-dollar question becomes, how in the world do you smooth out that chaotic blue line? Well, the answer is actually something you use every day, just on a mind-bogglingly massive scale. We need a giant battery for the grid.
The idea is actually incredibly simple. Think about it. When the sun is blazing and the wind is howling, we're often making way more clean energy than we can use at that moment. So, what if we could just take all that extra electricity and stick it in a giant savings account? Then we could just make a withdrawal later when it gets dark or the air is still.
And that, my friends, is exactly what grid energy storage is. It's not just one thing, but a whole collection of technologies all designed to do that one job. Soak up extra energy and then push it back onto the grid exactly when we need it most. It's the ultimate tool for balancing that high-wire act.
And it really is just a simple 1-2 punch. Step 1, charge. The system basically inhales all that cheap, abundant, renewable power when nobody needs it. And step 2, discharge. It breathes that power back out, filling in those valleys and shaving off those peaks we saw earlier. It literally transforms an unpredictable power source into a totally reliable one.
Okay, so when we say grid battery, what are we actually talking about? Well, it's a whole family of really cool technologies. So let's take a quick tour. Over on one side, you have the original gangster of grid storage, pumped hydro. The concept is genius. You use cheap extra electricity to pump a whole bunch of water up a hill into a big reservoir. Then, when you need power, you just open the gates and let the water flow back down through a turbine. It's still the king, with an incredible 181 gigawatts of capacity around the world. Then you've got the new kid on the block, lithium-ion batteries. Yep, the same tech that's in your phone, just scaled up to the size of entire buildings. And these are the fastest growing option by a long shot.
But here's the thing, you need different tools for different jobs. This table really lays it out. Lithium-ion batteries, they're amazing for short-term stuff, balancing the grid for a few hours. But what if you need to store that bright summer sunshine to use in the dead of winter? For that, we're looking at long-duration storage, things like flow batteries, compressed air, or even green hydrogen. These can hold on to energy for days, weeks, or even whole seasons.
Now, as amazing as all this storage tech is, it's really important to remember that it's not a silver bullet. It doesn't work alone. It's just one, albeit very important tool in a much bigger toolbox we need to build a truly modern, flexible grid.
So yeah, energy storage is the star player, but it's part of a team. We've got advanced weather forecasting to predict when the wind will blow. We have programs called demand response that actually pay big factories to use less power during peak times. We still have flexible power plants that can fire up quickly. And building better connections between regional grids helps smooth everything out. All of these have to work together.
So when you put it all together, what's the big picture impact of all this? Well, it's not just a small upgrade to our system, it's a full-blown revolution. And if you remember one thing from all of this, let it be this. Energy storage isn't just some backup generator. It is the key. It is the fundamental piece of technology that finally lets us build a grid that is reliable, affordable, and powered almost entirely by clean wind and solar energy.
And this revolution is already happening, all thanks to this one incredible number. Between 2010 and 2023, the cost of lithium-ion batteries dropped by a jaw-dropping 90%. That unbelievable price drop is what's making huge grid-scale batteries affordable right now, not in some distant future.
And that really just leaves us with this one powerful thought. For the first time, the key to a 100% renewable grid is actually in our hands. The question isn't really if we can do it anymore. It's how fast we're going to build that clean-powered future. Thanks for joining me.